record. Okay, so if you want to listen or watch the lecture again, Joanne has been very kind enough to uh, tape or video the lecture so that you can watch it again and again and again and again. You notice, I hope you know by now that my test, it's whatever we've taken up in class. So you just listen to it again and again and again. And a little bit of critical thinking is how I want to approach the study of A&P. But a lot of students say that watching the video again and again has helped them a lot. Okay, so today we start with our muscular system. It's just introduction today, so that when we study muscle physiology next week, it will be very clear and it will make sense to you guys. Okay? Okay. Chapter 9, isn't it? Chapter 9, muscular system. Of course, as far as the muscle is concerned, muscle tissue, I want you to know by heart the three types of muscle, right? Skeletal, cardiac, and smooth muscle. You need to know all three of them. See, it's right there. Now it's there. Okay? Skeletal, cardiac, and smooth muscle. You know, in your test, the take-home test that I was giving you, that's part of that, right? Compare the three of them. So be able to compare them under the microscope, histology, what you see, right? Striations, the number of nucleus, and then where do you find them? Nerve innervation. You should be able to differentiate the three of them. There's only three types of muscles, so I require you to know the difference between the three of them. This slide I lifted from the other book, Tertora. I thought it's very nice because it has every single difference that you can find as far as muscle is concerned. Okay? Okay, so it's very important for us to know the function of muscle. What does muscle do for us? So we know that it's the one that moves. Actually, what moves is your bone, mainly, right? Well, it does move. When it contracts, it moves. So it moves your bones, and then internally, you know that. By the way, don't forget in your final exam, that's why you need to know the function, because there will be a section where you will be asked, what do you think is the basic tissue type of the following? So, first of all, you should know by heart your four basic tissue types: epithelium, connective, muscle, and nervous. So maybe I'll ask, what do you think is the basic tissue type that moves your blood? So you're going to write muscle. Moves. Anything that involves movement is muscle. Okay? Maybe I'll say, people will make a mistake. What is the basic tissue type of the lining of the heart? They're going to write cardiac muscle. The word lining is not muscle. See? It's epithelium. So pay attention to keywords, okay? So look at, it's the one responsible for moving substances. It generates heat. So don't forget, when muscle contracts, it uses up so much power that it also gives off heat. The blood is the one that distributes that heat, but it's the muscle that generates that heat. Don't forget that. Okay? And then, and that's why when people have a stroke, right, you have that part that had a stroke, it's no longer able to give off heat. It's cold. You have to put a blanket or a sock or whatever. That's the one that generates heat. Let's look at the properties of muscle that makes it possible for them to do their job. Look at, very important for you to see this word, appreciate this word, excitability. The muscle is so dependent on a healthy nervous system. It has to be excited first. Excited means to stimulate. Nervous tissue is excited. That's the only one that gets excited as far as the tissues are concerned. I know you have some friends maybe who had a stroke. What's their problem? Nervous system, right? Not the muscle, but they can't move the muscle anymore. But the muscle is healthy. Now it will explain if you have some stroke patients, they can't swallow anymore. Because swallowing is a muscular activity, you see. Or sometimes you have to give them purified food because their GI tract, that's muscle. If the nerve to that muscle has been cut or has been injured, GI tract will be compromised. So you see some stroke patients constipated. You see some of them, you have to insert a catheter. No longer nervous was where was the problem? Was it muscle? No. It depends on nervous system. You understand this excitability?
Does it not work because the nervous system can't repair itself?
Very good. Yes. Isn't it the two of them? Isn't it? They're bad partnership. Nervous system cannot repair, muscle cannot repair also. Both of them are very sad story for them, right?
Yeah.
But they both are partners. That's true. Nervous system cannot repair itself. Okay. Contractility, we know this, right? Can contract. Okay. Then extensibility, the ability to stretch without damage. So look at when I'm contracting my elbow. Look at this one. What's happening to this muscle over here, the triceps? I'm stretching it. No problem, right? But what helps this to go back, because it has to go back to its original length, is its elasticity. There are elastic fibers that is part of your muscle tissue. Elastic fibers, which is what type of tissue? Epithelium, connective muscle, or nervous? Connective tissue, very good. You see, I told you, elastic fibers is the favorite target of what common lifestyle among people? Smoking. So you see, you have elastic fibers here. Smokers have that specific wrinkle, right? You will see elastic fibers in your aorta. You're taking Bio 242, you see elastic fibers in the aorta, so they become hypertensive. Elastic fibers now in your muscles. You will notice that some smokers will complain of muscle aches after a long time of smoking. Some of them will experience muscle aches. They get tired, or maybe they will have problems with uh, not only movement, the heart. Wherever there's muscle, there's elastic fibers, and always think that's the target of cigarette smoke damage. How do you get the chemicals from cigarette smoke? Well, once you inhale, right? We were just studying the respiratory system yesterday. Look at, you inhale that cigarette smoke, the blood vessels in your lungs picks up those chemicals. Where's the blood going to go? Everywhere. And that's why it will damage your elastic fibers. You understand? Okay? It's just not a good habit to start or to continue. It would be nice to stop that smoking. So, okay, the best way to study our skeletal muscle is our muscle is by looking at skeletal muscle. Before we start, I want you to know these terms. Okay, origin, insertion. So, you know that muscles always have two attachments, your skeletal muscle, right? So, like this example over here, the origin is the immovable attachment, and the one that moves is called the insertion. Okay? So let's say your biceps, the origin right here, and it will insert. The insertion of any muscle always will go over a joint. Does it make sense?
Mhm.
If a muscle originates and inserts on the same bone, if it contracts, it's not going to move, right? So it has to always go over a joint. So like your biceps, origin here in the humerus, insertion here in the radius. See? So it will move. You understand that origin insertion? I'm going to ask you that in your test, okay? So figure out where do you think is the origin, where do you think is the insertion. That's how they move. How about agonist and antagonist? They're opposite, right? They're enemies, the agonist and the antagonist. The agonist is your prime mover. It's the one that accomplishes the movement that you want. Like I want to flex my elbow. What's the agonist here? Must be my biceps. You know your biceps, this one right here, right? So this is the biceps. When this contracted, it caused flexion. And that's what I wanted. So what's the antagonist? This one. It's opposing it. Okay? An antagonist is the one that opposes the movement that you want. So for this elbow flexion, what's the antagonist? My triceps. You understand? Then synergies are your helpers. So here for elbow flexion, you have your brachioradialis. It's helping. So agonists and synergists, they're doing the same action. Okay, both of them accomplish your mission. So in this example, we used elbow flexion. The antagonist in our example is the extension muscles. Okay, and then you know these three: hypertrophy, atrophy, hyperplasia. So hypertrophy is in these two refers to size. Okay? Hypertrophy is increase in size. You're bulking up. When you're exercising, you're weightlifting, you see you're bulking up. That's hypertrophy. Atrophy, decrease in size. There's actually two types of atrophy. I'm sure you've heard of denervation atrophy and disuse atrophy. So denervation atrophy is when the nerve gets cut, right? So you're not, it won't contract anymore. If it doesn't contract, it atrophies. It thins out. Disuse atrophy is just like Baba. I like to use my Baba. When he's not, when he exercises, he bulks up. When he stops exercising, what? Thins out. You're not using it. Disuse atrophy. You see the difference? Like some people have a membership at the gym and then all of a sudden they stop the membership. See, the muscles, they start thinning out. But what happens when we're born, right? The moment we're born, we're born with a set number of muscle cells. It cannot increase in number anymore, which is hyperplasia. Hyperplasia always refers to increase in numbers, which is one of the key words that they look for when diagnosing cancer. Presence of hyperplastic cells. So anytime you see the word hyperplasia, increased number, increased cell division. And we know that muscle does not divide anymore because what's absent? Yes, very good. No more centrioles. So this one, this hyperplasia, happens in utero, inside your mother's uterus. While you were being formed, you were forming, increasing the number of your muscle cells. But at birth, that's it, the cell division stops for muscle. How did you increase the size? You just pack it with whatever is inside, the muscle proteins. Just like the pillow, right? You have fat pillows. If it's filled with, what do you call the stuff inside pillow?
Stuffing.
Stuffing. If it's filled with stuffing, you can take out some of that stuffing and the pillow thins out. That's all. It's the stuffing inside that will make you bulk up or decrease in size. Remember these terms, okay? Because maybe I'll give you a pop quiz on A and P terms, so you should be familiar with terms. Okay? You understand? You have any questions on those terms? Okay, so I have this picture here of skeletal muscle. And I want you to look at, so here's your muscle. Before, when you go home, or if you're gonna have your chicken, I'm going to call Safeway. If you're going to have your chicken or your steak, okay, before you cook your chicken or your steak, look at it. You'll see that, you see the importance of connective tissue. Connective tissue is the base. So there's the individual cells, see? Something must glue them together. So what we know of as biceps, let's say, it's really made up of individual muscle cells. See? And what connects them or glues them together is this connective tissue. You look for that in your, when you, before you cook your chicken. You see this like a white fiber, you see the separation, okay? But look at this picture. Look. The connective tissue, all of them, they group together or collect right here to form, this is your tendon, isn't it? The tendon. And what is the basic composition of this one? No. What type of tissue? It's collagen. Collagen. Okay? This is collagen. And what is the main protein here? Isn't it also collagen? Isn't it? Right? This is also collagen. This is one and the same. This is collagen. It's both the same. Except when you get to bone, what happened to the collagen? It has been, yes, very good. It has been calcified. Very good. It's been hardened. See, it's one and the same. This, in fact, they call it Sharpie's fibers. But the fusion is very, very strong, they say, that you have a tendency, more of a tendency to break your bone than this one over here. Okay? So, why do I want you to concentrate on this one or to know this? To understand that when muscle contracts, look at, when muscle contracts, it's going to pull on both ends, right? Except that one is the origin, one other one insert, so it's the insertion that will move. But it's actually, yes, muscle moves, but indirectly. It is causing tension on the tendon, actually. And the tendon is the one that will move your bones. That's why, have you heard of tendinitis? You ever had tendinitis? Some people with tendinitis, where's their problem? Is it muscle? No. It's the tendon. And yet they can't move. See? It's the tendon that is the key. And this tendon, one of the things about tendons, it has a very scant blood supply, not that much. And that's why when it gets injured, the healing is just very difficult. For one thing, it also secretes factors that prevents the sprouting of new blood vessels. It's very difficult. So it takes a long time. So that's why. Does it make sense? You see? The muscle was not injured when you have tendinitis. This is the one. Or a ruptured tear right here, a torn Achilles tendon. All of a sudden, you won't be able to move. But where's the problem? Is it muscle? No. It's the tendon. Okay? Okay. So I want, before we study our muscle physiology, we need to know anatomy of the muscle. Okay? First of all, you know now, anything that starts with keratino refers to what body system?
Skin.
Yes, integumentary system. Don't write skin. Integumentary system, okay? Anything that starts with osteo, right, skeletal system, not bones. Okay. It's okay. It's okay.
We just had a test.
I'm just being, what do they call that? Anal, right? I want to see the correct word. But I know what you mean. So at least you know, right? Okay. Now, when we refer to muscle, you should know that anything that starts with myo or sarco refers to your muscles. Okay? When we get to the nervous system, it will be neuro. You see, they have keywords. So, I know that you are, where's my, here. You're familiar with the common shape of a cell. It's round like this, right? What's this part of the cell? Yes, very good. This is the, yes, cell membrane, and this is the cytoplasm, where you have the cytosol and the organelles. Look at a typical muscle cell. It's cylindrical. So they're just showing you a portion, but it's really, it's long like that, right? Long, and then there's the tendon right there. Okay, so it's cylindrical, so that it can do its job properly, contract and pull. Okay. Now we're going to look at what do you think. What do you think is a typical muscle cell made of? It's very important for us to know the contents or the ingredients, the vital ingredients of every muscle cell, so that we can understand muscle physiology. Look at, this is skeletal muscle. We know that it has nucleus. Look, because it's skeletal muscle, it has one, it's multinucleated, see? Many nucleus. If it's cardiac muscle, just only one, right? Smooth muscle, also just only one, okay? And you see this one, these are the muscle filaments, the muscle proteins that carry out that muscle contraction. You're right there, Brenda. That's you, right? Right there, that slide there is skeletal muscle. So you see, you have, that's what leads to the striations over here. So muscle, you know, they're showing this one as just maybe a few, but what you need to know is it's filled with muscle. It looks like this, filled with the muscle proteins. They're just showing us what is present. Do you understand? Do I make sense? Okay. It's not just, in other words, muscle cells don't have only these two sets. It's filled with muscle proteins. And I want you to know the two important muscle proteins, actin and myosin. Actin is your thin filament. You remember from chapter 3, your microfilaments? These are your filaments. Actin, oh, I don't know how to spell. Where's the letter T? Actin, that's your thin. Thin for thin. That's your thin filament. And myosin is your thick filament. How I try to remember, also it takes longer to say the word myosin. It's 3 syllables. Well, actin is only 2. Actin, you're done saying it. It's a thinner word. Okay? So those two filaments in regular arrangement right here, those are the key for muscle contraction to happen. You follow? So what is muscle made up of? The bulk of it is these muscle proteins. They're the key. When they do what they're supposed to do, when they slide past each other, see, imagine, they slide. So you're going to pull from end to end, muscle shortens. Okay? Everybody so far? So we know that there's nucleus. Okay? There's actin, myosin. What else do you think does muscle, what does muscle need so it can do its job, contract? What did you say? Elastic fibers, yes, but that's over here, okay? What else? So it can contract, you need to provide it with, very good, with energy, okay? What is the main source of energy? Protein and fat? No. What is your main source of energy? It must be carbohydrates. Don't forget, fat is stored energy and fat is lipid. Okay? And then protein, you don't even use it for energy. It's not recommended. Remember that? We talked about that, chapter 2. So it's it's carbohydrates. Isn't that the main energy source? So look at what every muscle cell has. It has, look at this one. It's called glycogen granules. It is stored in what you call, do you remember? inclusion bodies. That's where this is stored. You see that? Amazing, isn't it? Muscle already provides its own energy. Remember, you store glycogen where? In muscle and nerves. Sorry, not nerves. Liver, muscle and liver. Okay, so look at this one, okay? So we know why they have these muscle proteins. We know why they have nucleus. It's a cell, right? And besides, nucleus is the key for protein synthesis. These muscle proteins are made by protein synthesis. They're not just magically present in every muscle cell. Don't forget that, right? That's why when we exercise, we can bulk up. Where did they come from? This one, protein synthesis, okay? So they have this one. What is this? Yes, very good. It's the mitochondria, which is what?
The powerhouse.
Yes, the powerhouse. So you see, muscle, it has this one, right? You need to convert it to the gas called ATP, where? In the mitochondria. What does the mitochondria need to do that? No, what?
ATP.
That's what's produced here. What does the mitochondria need?
Cellular respiration.
Yes, what is it?
ATCL.
Letter O.
Oxygen.
Oxygen. Oxygen. Very good. Oxygen. Remember? So remember, the glucose will go here. You convert it to ATP, but the mitochondria needs oxygen. Where is the oxygen coming from?
Blood.
But where did it come from?
The lungs.
From the yes, very good. From the air, right? You breathe it into your lungs, and you said the blood, right? Do you remember? Where is it going to go? Inside the red blood cell, bound to what?
Hemoglobin.
Yes, very good. Hemoglobin. Are you familiar with hemoglobin? Right? Look at what muscle has. It has its own. It's called myoglobin. Isn't that amazing? It's like it's the hemoglobin equivalent of muscle cell. So can you guess what myoglobin does? It binds oxygen. Amazing. So we breathe in oxygen, the blood delivers it to muscle. So while it's in the blood, it's riding on the hemoglobin compound of your RBC. Then when it goes to the muscle, the oxygen leaves the hemoglobin and it binds to your myoglobin. This way, muscle has a ready oxygen source, you see? Because muscle is always contracting. Do you agree? Muscle always contracts, right? You heard of muscle tone? Why do you think you're able to lift your head up like that? Right? Vegetables, they cannot. So muscle is always contracting. So they have a ready source of oxygen. You understand our different key features of the muscle so far? Understand? No questions? Everybody? You understand so far? You see your nucleus, you see your glycogen. You understand? Yes?
Muscles the only cells that have special oxygen.
The myoglobin, red blood cells also have the hemoglobin, right?
Are there other globins?
Other globins is no. Well, there's immunoglobin, immunoglobulin, but if you're asking, is there any other oxygen binding?
Right.
No.
That's
Very
So
interesting, isn't
probably
it?
muscles are the last things to like. If you are suffocating, your muscles probably won't be very affected. You can have their own supply.
Maybe, yeah, because it has its own blood supply. In fact, when you die, don't you go? I'm sorry, not when you die, but people when they die, don't they go into rigor mortis? So they go into that stiffening. You know rigor
but
mortis,
then
right?
it goes away too, doesn't it?
It goes away, but you see, even though you're dead already, you're still contracting because it has its own oxygen. I'm just guessing.
Well, is that why, like, say you're being strangled and your oxygen's cut off, you'd be able to fight because, or with your muscles and all that, because you have those two already there.